happens when we're doing derivative. Sine 3x is actually cos, the inside is 3, of u times u prime. Next one, the same kind of deal. Derivative of cos this time is negative sine. The inside doesn't change, x squared plus 5, and then I multiply by the derivative of x squared plus 5, which is 2x. Next one is tan. Derivative of that is secant squared. This time, the u would be x to the power of 5 times the derivative of that, which is 5x to the power of 4. And last one, this time my whole u term, I rewrote this as secant u. The derivative of secant is secant tan. My u in this case is sine x tan of sine x times the derivative of sine x, which is cos x. So every time this happens, every time I take the derivative, I have to multiply by u prime. Negative sine u, I have to multiply by u prime. Secant squared u, and I have to multiply by u prime each and every single time. Secant u tan u times u prime, negative cosecant u cot u times u prime, and negative cosecant squared u times u prime. That's how differentiation works. Chain rule, multiplying by the derivative of the inside. Multiplying. So when you do integration, because integration is the opposite of doing the derivative, you might imagine that, oh, opposite of division, opposite is division of multiplication. So therefore, instead of multiplying by u prime this time, we'll probably divide by u prime. So that's kind of how it works out. Integral of cos is sine u divided by u prime plus c. This u prime on the bottom can be problematic because you might just think, oh, okay, I can use this entire thing as a formula and I never even have to worry about taking the integral. I can just go straight from the integral of that, bam, to this, which most of the time that works, but it doesn't always work. So you can't just use it as a formula. You can't just plug it right in all the time. You have to worry about canceling your x terms off, as we'll see in the next examples. Negative cos u all over u prime plus c. Tan u all over u prime plus c. So each time I'm dividing by u prime instead of multiplying by it. This is going to be equal to secant u all over u prime plus c. Negative cosecant u all over u prime plus c, and the integral of cosecant squared is negative cot u all over u prime plus c. Okay, so here it still wants us to show what u equals and what du equals, so we still have to go through and find each one every time. So we start off with our let statements. We're going to let u equal 5x this time, which means that du is equal to 5 dx. And if you want to do it Mr. Howell's way, you divide, right? Okay, dx is equal to du over 5. And then you kind of know what your coefficient is. It's going to be, well, 1/5 times the integral of cos u du. So nothing to cancel here this time. You just go straight across, which is going to be 1/5 times the integral of cos is sine. U was 5x bracket plus c. That's your final answer. So make sure that you substitute in your value for u. Next one. I'm going to let u equal the inside, which is x squared plus 9, which means that du is equal to the derivative of that, which is 2x dx. This time I'm going to do the fast way, Mr. F's way, which says look to see what matches, right? The x's match. I can cancel them off. So I'm basically just left with the integral of, what's the coefficient in front? Well, look at the 2 here. Remember that that's going to be reciprocated. So it ends up being 1/2. Then I get sine u du. What happened to the x? Oh yeah, it fell away. So when I take the integral of this, I get 1/2 times the integral of sine is negative cos. U was x squared plus 9 plus c. Next one, secant squared. So, again, start off with your let statement. Let u equal. Pi is actually pronounced p. I didn't know that. So it's actually pronounced p x, because in Greek, I is pronounced e, but that's alright. So du is equal to just pi, or p, dx. Again, you can do it my way if you want. I don't know. That means you get du over pi, so it kind of illustrates better why it's 1 over pi in front. And then you get secant squared, which is secant squared u, and that's du. Then I can take the integral of secant squared, which is tan, so I get times tan. U is pi over 6, or pi x, sorry, pi x plus c, and that's your final answer. It's done. Next one I have is cos root x. Well, this time it might be kind of hard to see what you want to let u be, but we're going to let it be basically x to the 1/2. And a hint for that is, if you look at the bottom here, it's a root x. Well, I can't really do anything with that, but what I can do is get rid of it if it cancels. So if I let u equal x to the 1/2, my du is going to be 1/2 x to the negative 1/2. We can clean that up a little bit. We could say that that's equal to 1 over 2 root x. And then again, you can look at this on the bottom here, matches the one on the bottom there. Therefore, it cancels. But keep in mind, what happens with the 1/2 is you have to take the flip of it. So it's actually going to be 2 times the integral of cos u du. The root x in the bottom is gone because it canceled with that one there. That's equal to 2 times the derivative of cos, or times the integral of cos, which is sine. U is x to the 1/2, or root x, plus c, and that one is done. Number 21 here, again, always let u, or most of the time let u equal what's kind of on the inside of the brackets, or kind of what's the more complex function. So let u equal sine x. So du is going to be cos x, and you can kind of see right away, oh, okay, there's the cos x, matches with that cos x. Those are the things that cancel. We got the dx there. So you can cancel off the cos x's, and you're left with the integral of, there's no coefficient now, right? Just sine of u du, which is just cos negative cos, and u was sine x plus c. So, last one on this page, integral of 4 sine x over 1 plus cos x squared. So again, let u, pretty clear what the more complex one is, and it's in brackets. So u is going to be 1 plus cos x. just what's inside, which means the du is going to be equal to 1 is 0, cos x is negative sine x, dx, and then you can see right away there's a sine x, there is a sine x, they're both on top, they cancel, but I have to keep in mind that the negative sign is going to carry through, which means that I get negative integral of 1 over 4 over, and the inside here has become u squared. The 4 we can take out because it's a constant, and I can rewrite this as negative 4 times the integral of u to the negative 2, forgot the du there, du. Always write it as a negative exponent, so then I get negative 4 times u to the negative 1. I increase the exponent by 1 and put it over that new exponent, plus c. And to clean this up a bit, negative 4 divided by negative 1 is just 4 over, because it's u to the negative 1, and there is u over there, it's 1 plus cos x, all plus c. That would be my final answer. So, last page. So we're going to let u equal just what's here, which is 1/3 x, which means du is equal to just 1/3 dx. Keep in mind that this here will reciprocate, so it becomes 3 times the integral of cos u du, which is equal to 3 times integral of cos is sine. U was 1/3 x du. Sorry, not du. Du is gone. Every time we take the integral, du is gone. Plus c. 24. Same kind of deal. Here I have cos squared of 2 pi, or 2 theta. So I'm going to let u equal 2 theta, which means that du is just equal to 2 d theta this time, because my variable is theta. That's my d theta. So we can see that what my coefficient is going to be 1 over 2, right? If I solve for d theta, I would get du over 2. That's like 1 du over 2. So I get 1/2 times the integral of cosecant squared u du, and the integral of cosecant squared is negative cot u. So I get 1/2 times negative cot, u is 2 theta, so I substitute that back in, plus c. Last one here, 25, next one. Secant squared. So again, let u equal pi x, which means that du is equal to p, or pi, dx. So that means my coefficient is going to be 1 over pi times the integral of secant squared. Pi x becomes u du. Take the integral of that, I get 1 over pi times, and the integral of secant squared is just tan, so it's basically just tan. U is pi x plus c, and I'm done. I'm going to start off with letting u be equal to r cubed, because that's kind of what's inside brackets here. And I can also see that if I take the derivative of this, I get 3r squared, and the r squared is right here, which I want to cancel. So du is going to be 3r squared dr. There is my r squared, which matches, so they cancel. And I'm left with the 3, which is going to be 1 over 3 times the integral of secant squared u. So the r squared in front of the secant is gone because it canceled that one, and the 1/3 comes from the fact that I have a 3 there and I have to flip it. du, which is 1/3. The integral of secant squared is again just tan. U is r cubed, and that's all plus c. Next one, this should actually read secant of x. So I'm going to let u equal. If we look at this one here, we have a hint because the thing's inside the brackets here. That's what I want to make u. And also, if I take the derivative of secant x, I get secant x tan x dx. Oh, that matches that, and those cancel. So whatever matches cancels off, which makes it a lot simpler. Is there any coefficient? Nope. So it's just the integral of cos u du. Everything else, the secant x tan x, is canceled away, and I'm left with just cos u. Integral of cos is positive sine. My u was secant x plus c, and that's my final answer. Last one. This one, you can do a number of different ways. You could let u equal a bunch of different things, and you could get off on a very wrong turn and start heading in a bad direction. So I'm going to start you off in the right direction. We're going to let u equal. Probably the simplest one to have it equal is sine of x over 5. A hint for that one is I can look at this one, the first one here, which is my more complex one, sine squared of x over 5. And if I just let it be sine x over 5, we'll see that, oh yeah, the derivative of sine is cos, which matches this one, which will make that one disappear, which is what we kind of want. So du is going to be actually equal to cos x over 5. Keep in mind that we have to use the chain rule, so I have to times that one by 1/5. So the derivative of sine x over 5 is cos x over 5 times the derivative of the inside, which is 1/5 dx. So I can see right away, there's my cos x over 5, which matches that cos x over 5, so they cancel. And keep in mind that the 1/5, you have to take the reciprocal of, so it becomes 5. Times the integral of sine x over 5 is actually u, so that's going to become u squared. Because it's sine squared x over 5, I got sine x over 5, u squared du. Almost done, so I take 5 times, this becomes u cubed over 3 plus c. Substitute back in for u, which was sine cubed x over 5 plus c. That's sine cubed x over 5. Let's make that smaller. And that's it.